this is last class I taught non-negative matrix factorization. It can summarize as this. This is the original samples. It can decompose into two matrix. It requires these elements in this matrix must be non-negative, and require both of these two matrix elements they are all negative. So it can express as this. Non-negative for image. Of course, this can be are real numbers, but for image is pixels, so it's integers. So everything is okay. I just take the image as example. It's 3 levels, so it's maybe between 0 to 255. This is the two matrix. I want to use this image to express every column. This is every column of this matrix. For each column, such as VI, can express this. So this is every pixels of VI, and this is all of the W, and this is the corresponding to this pixel to this vectors. This is the coefficients. Use these two to express this. This is every column's situation. So as last class I will see this. How we can?
That one is the VM.
We are.
No.
W.
No. The V. Yeah.
VM.
VM, yeah.
Yeah, VM. VM. So every can express as this for every column. This is such as the face. They have base, every base, and this is coefficients. So every element there is non-negative, and I also after we decompose, we find every element there is a part of our face. So this principle is used the part to express the whole face, and so after we can this in last class I said I will how to factorization this matrix. I will have object function. You remember log function. It's like this. Last class, Sam asked me how to can obtain this object function. Remember this function? I would like to say, based on this, I said a model that we sample the numbers of every face there, or the element there is it satisfies the Poisson distribution. You know, Poisson distribution requires the sample is non-negative. So it's just like I require this Poisson distribution. This is the mass distribution of Poisson. this is distribution that it about this is the parameter. This is every I think 1, 2, 3, 4, 0, and then all of this distribution. I suppose it's every element here is satisfies the Poisson distribution. So we know in Poisson distribution, if some primitive distribution, if x is a distribution, then his expectation is lambda. You know this. Need I inductor this. This is all this the variance is lambda. So in average we say we can expose that every element of this matrix we will think the real number. So its real number expect is every lambda. I mean it's lambda. Can you this is the distribution is this, so we can write a lot of we can write a lot of Poisson distribution. It's about n by m because there are so many elements. So the distribution here is n by m. It's so many. So it's likely who the function is. Likely who the function. Function can express that this is the samples. You know, we already know this. Every element samples. This is our expression here. So the overall likelihood function can be expressed. This is the multiply symbol. We can multiply all the function in this domain. Yes. You mean this?
No.
This?
No, the left side. Yeah. It's N.
This function. This is about it will activate this as a parameter. It can activate this. Sorry. I must also.
This one is your likelihood.
Yeah, likelihood function. So this vector function we can use the log function and to let the multiply function to become addition function. So this is let's get this. This log function here. Just this we can get this.
What's your WHI? I guess you need to write
WHI,
Yeah.
you missed the U.
WHI.
The right side.
Oh, this.
No, the right side.
This.
WHI.
Yeah,
This
yeah.
is this.
Yeah.
Oh, this is for example, this matrix. Just this multiply matrix element here. Every element in this matrix. This matrix.
But then, so you said like a column or like each element. So you're counting as element.
Yeah, each element we will use this to estimate just same as the.
But you I only from 1 to m. You have like m and so many elements, right?
It's a
It's
column.
IU, I think, yeah. WHI.
The
Uh,
subscript.
This.
Yeah, IU or just
Oh,
I.
I will solve it. Okay, here. This.
Okay.
Oh, sorry, a little nervous. This we can use log function to decompose this, and this is
What's the difference of WHIU and VIU? What's the difference of like, you say V is equal to WH, right? So when you say like the IH element, IU element of WH is like...
yes, every element. I don't use the. Sorry, I don't use this symbol. Just must sum together.
Yeah, but how, what, okay.
Let me write down it. I can.
Okay.
Okay. This is constant. Example, this is constant, so it can throw away this part. Do not affect the over functions. So if this part can get a maximum, this is not this is constant. So we need not consider this part. So just like this. This part is equal to this part, except this constant. We need to consider this. So this is the procedure of this of the log function. some question.
Your L2 is the same as L, right? Or like what? What's
This,
the L2 is?
yeah, is a log function of this.
Okay, okay.
So this is we get this. So we can get this object function. When we get the maximum probability, we think it is the optimal situation there. So based on this object function, we can get this updated rules, but have any other rules, updated rules. This is multiplicative rules, and have additional rules here, but maybe run slowly than this. But I will talk about how to this rules in next my topic. It may need a lot of time, and I will review some paper. That's it.
So that's missing a minus sign. I mean the first term like L2 missing a minus sign. You take the log there like this. It looks like there will be a minus sign. I mean the expectation W.
It is not
Oh,
this
sorry.
time. It's bracket.
Oh, it's a, okay. That's
I think
it's a
bracket.
bracket. Okay.
Yeah.
Okay.
It's-
Sorry. I expected something.
This is V application is
No,
just
okay.
use it to satisfy this distribution here. And the IU here, WH here, Poisson function is non-negative, so it can use in this situation here. But just I want to say that non-negative function as other decomposed methods such as PCA and QR method.
Yeah. What's the difference of the WH and V? You said that the V is equal to WH.
Oh, WH we want to get W and H, but V and V is the samples. We get samples. Sample is V. We want to use V to
Yeah, I
induct
think the
W.
original notation is very confusing. His WH is actually the mean.
Yeah.
He's trying to estimate the mean there, like for each of the V element, basically.
Yeah, every element wanted, but it satisfies Poisson distribution. Here, maybe this. So this element it must be this. So it's it's not in this level. So we from the probability theory we use this lective function to get an object function. Just this.
I guess here you even didn't use any assumption that like whether the matrix will be positive or not, the elements, and also whether it's a multiplication of. I can just say WH is equal to V mean, right? It doesn't change anything. I can change all the WH here as like lambda. You know, it didn't use any structure for the moment.
Yeah, can use this. Just be careful. Use this. If some visible for some visible object, it may be useful. I think it's useful, but for some complex objects such as walking, this image, I have used method. It's not very good in this situation. But for face, some visible, including numbers, this is I think is a good approach. You can, if you have this problem, I think you can use this. This method has integrated in MATLAB. In MATLAB, you just have this function. You can use this. It's wrong. I remember after 2008B, it has this function.
It has a method has a input.
Yes, you just
for
input.
the
You need just input this vector
just vector.
and R is what you choose. Then he can give you this information and you can factor.
But last time you said the dimensions of the matrix have some constraint. R times m plus n is less than m multiply n.
Yeah.
So how do you show this constraint in this mathematical function?
Oh, this is you mean this?
Yes.
Oh, I want to say that it's based on some function, but I assume you have just select R. Selector is what you choose, your choice.
Okay.
It's what your choice, not this. You must choose the R. Any other question?
For the difference or how this function can work.
How
For
this
the
function?
difference or
How this function can use the
no. I mean you said that the R is the input parameter, yeah?
what?
The R,
R?
yeah.
Oh,
Yeah, you said that the input of this function is R. One of them is R, yeah?
you mean this?
Yes.
Oh,
Yeah?
oh,
And you said that you can just choose
approve the R?
no, R. Is R?
Yeah. R is this
Dimension.
Yeah, I know. But yeah, you said that we can just choose one R, yeah, for that function.
one R?
Yeah.
I think you can. You just one image, one part. You just need one part. R, I think R stands for this is basics.
No, I know, but I said that for example, we just choose two different R.
Yeah.
Two different R and for example, R1 and R2, for example, and R1 is bigger than R2, something like that.
R1.
What is the result of the NMF?
Oh, generally.
I mean that this function is dependent on the R, of course, yeah, or not?
I mean, sometimes the R is, you must choose R based on the physical meaning. I think there is no optimal method of how to choose this R, but this requirement. For example, you must test different results. I think then you can find what is the best.
Okay.
This is just this. For example,
You mean for each example?
in face you can have nose. You can decompose nose, and two eyes, and this and this. So you can select so many R and test the result, and just little adjust this.
Okay.
This is